All right, so for each of these, use an equation inequality statement to compare c squared with a squared plus b squared. So when you write it, always start with your c squared, and you're going to either do some value, and it could be less than, it could be greater than, or it could be equal to. We're not sure which, right? And then a squared plus b squared. Make sure you don't have any spaces when you write it. And in this case, our right angle, and you can kind of tell by what looks like the right angle. You can also tell by the c squared should always be the biggest value when you square it. And so this is going to be like 13 squared compared to 3 root 15 squared plus 11 squared, right? And so 13 squared is just 169. Now when we do this, remember, you apply the square to the 3, so that becomes 9 times 15, and you can just calculate that, right? Because the square cancels the square root on the 15, but you have to square the 3 in front of it, so that's where you get 9 times 15 plus 121, and then you just compare it, and you write it. Now, if the c squared is bigger, right? So if the c squared is bigger, it's obtuse, right? If the c squared is smaller, it's going to be acute. And of course, the easiest one is if c squared is equal, then it's right. All right. Oh, uh-oh. That was a mistake. Yeah. Right. Right. All right. Same thing over here. We'll switch up colors. Same thing you would do, once again, this is our right angle across. So we would do 15 squared compared to 14 squared plus square root of 29 squared. And you would just calculate it out, write it as a statement here with the numbers. And so if the c squared is bigger, it's going to be obtuse. If the c squared is smaller, that means it goes in, it's going to be acute. And if the c squared is equal, that's when it's right.